Welcome to Let's Talk Science. My name is Daphne Pariser, and I am the CEO and founder of Humans for Education.
And I'm Stephanie Monticelli, Program Director at Humans for Education. And last week, we briefly talked about immunity and COVID-19, but today we're really going to take a deep dive into that topic. And to help us with our discussion today, we're excited to be joined by Dr. David Topham. Dr. Topham is a professor of microbiology and immunology, a member of the David H. Smith Center for Vaccine Biology and Immunology, and he also co-directs the New York Influenza Center of Excellence at the University of Rochester. He's also served on IBM's Global Pandemic Steering Committee. Primarily, his research interests are in the area of immune responses to influenza and experimental vaccines, but currently he's expanding his research to also include COVID-19. So thank you so much for being here today, Dr. Topham.
Oh, you're welcome. It's a pleasure.
So tell us a little bit about why immunology is so important for COVID-19 right now.
Well, immunology is important because that's the part of your body that fights the virus and eventually eliminates it. It's a double-edged sword of sorts, in the sense that in some people the immune system can get overexcited and you get excess inflammation. Some people call it a cytokine storm, and the immune system can actually cause damage. So it's a fine balance to achieve an immune response that's effective at controlling the virus, but not too strong so that it damages the host.
And is that what's really happening with COVID-19 right now? Are we seeing cytokine storm in people with COVID-19?
You know, I would say it's still controversial as to what exactly is happening with COVID-19. It's not just a respiratory infection. We're now finding out that it infects the intestine. It infects endothelial cells that line our blood vessels. And you've heard probably a lot of these stories of people who have had blood clots or strokes or cardiovascular issues. And we think that's because of the way the virus affects the lining of the blood vessels. That disrupts the coagulation system, leads to blood clots, which obviously are problematic. So although it's spread as a respiratory pathogen, this actually it's a multi-organ infection.
So can you tell us a little bit about the studies that you guys are doing in your lab to educate more about the immune system and, a little bit more about what you guys have learned so far and how that relates to COVID-19?
Well, we have a number of studies going on. One of them is looking at people who have recovered from COVID-19 infection to characterize their immune response. I mean, that was obviously a successful immune response. And so, what are the hallmarks of that in terms of the kind of antibodies they make, their T cell responses, and how durable is that immune memory? Does it stick around for a long period of time, or does it wane very quickly? Because that'll tell us whether or not people can become susceptible to infection again. We're also doing studies in people with acute infection. These are outpatients, so they tend to have mild disease or milder disease. And again, we're trying to understand, because this is the first time anybody is seeing this virus, or the immune system is seeing this virus, the immune response characteristics are different than they would be for, say, influenza, because you've seen influenza many, many times over your lifetime. And so the kinetics are different. How the cells respond is different, and we really don't know, how this is going to go. It's also, studying infection is very important because it informs us what to look for in a good vaccine. So we're going to be testing vaccines soon against this virus, and we will look to the gold standard of a successfully controlled infection and what that immune response looks like, and see how much a vaccine can replicate that response.
Are you going to be looking at the vaccines specifically in your lab? Or are you going to...
Yes.
Okay. How are you guys going to be doing that in your lab?
So we're probably going to be looking at 5 different vaccines in the next 6 months. I don't know which one is going to come first. There are various platforms. You've probably heard of some of them out there. adenovirus-based platforms, RNA-based platforms. We'll be testing each of them, and my lab will study immune responses to those vaccines.
And which of them do you think is the most promising candidate, and why?
I have to be careful here. I'm not supposed to pick a horse. I need to remain unbiased. I would say that the live attenuated vaccines, so the ones that use viruses that are not necessarily pathogenic in people. Mm-hmm. So there's a chimp virus vaccine. There's another adenovirus-based vaccine. Again, the virus itself has been attenuated. But those, they tend to be what we call self-adjuvanting. Mm-hmm. They stimulate the immune system very effectively. And that gives you a more potent immune response and one that more resembles the actual infection. And because it is an infection.
Tell me, what is your thought on people who have previously been infected with COVID and their ability to be resistant to a new infection of COVID?
So there's not a lot of data out there right now, but there is some from both people and animal models. And it looks like someone that's been infected can get reinfected. Mm-hmm. In the case of the human subjects, again, these are preliminary studies. It doesn't look like those people, they don't get sick and they don't spread the virus, but the virus is present and it is replicating. I just heard yesterday of a study done in an animal model where the animals recovered, and then about a month later, they tried to see if they could reinfect them. They definitely got reinfected, but again, they had very little disease and virus was very difficult to detect, even though they could detect the RNA to the virus. So I don't know what that means. Even with seasonal coronaviruses, that circulate every year, there's only 3 or 4 of them that infect humans, and we get infected with those viruses repeatedly across our lifespan. It's not that you're, one and done as with some right. pathogens. Right. So if immunity to this coronavirus is the same, it's probably something that's not that durable. And again, studying the immune response to understand why it's not durable is going to be critical.
Right. And that'll also kind of give us more information about how often the vaccine then needs to be delivered to people, etc. Is that correct?
Absolutely. So I thought you were going to ask me the question, if somebody's been infected, should they get vaccinated when a vaccine is available? And my answer would be yes, because I think, anytime you have a chance to boost your immunity to one of these pathogens, that's usually a good idea.
And also just, I think to piggyback on that, I think one of the most important things is that everybody should be getting vaccinated to this, regardless of have they been infected, have they not been infected, what is their age range, are they kids, are they not kids? They should be getting vaccinated, to be able to create this herd immunity and all of these things, right? Yeah.
Correct. It's funny, I used to have to explain what herd immunity was to people because most people hadn't heard of it before, but now it's so widespread in the media that everybody knows what herd immunity is.
Everyone's an expert now.
Right. Nothing wrong with that.
So what have you learned so far about how COVID-19 actually interacts with the immune system in the studies that you've been doing?
Well, again, it's early days. We're getting pretty strong antibody responses. Mm-hmm. Interestingly, we have a small number of individuals who have recovered from infection and make antibodies to one of the antigens or proteins from the virus, but not the other one. They really should be making responses to both. Most people do. And we really don't understand that. And in at least one of those cases, if we look at the cells that make those antibodies and we stimulate them in culture, then we get antibodies to that protein. So for some reason, that's not accumulating in their serum. So, this virus has a lot of puzzles, and it's going to vary, as to who it infects, what their immune history is. And we need to understand that to be able to predict who's more or less at risk from developing disease or an ineffective immune response.
Do you have any ideas on why that might be? That seems so strange to me.
I don't, except that we know, unlike most respiratory viruses, this one actually infects T cells and B cells.
Mm-hmm.
So there have been reports from autopsy cases, especially, really severe disease, where the immune organs, the lymph nodes and the spleen, their structures are completely decimated. And that's also, we're seeing relatively low numbers of COVID-specific immune cells, a month after infection compared to, say, flu. And I think that's also because the immune system itself has been damaged. And so it makes it harder to develop a durable, healthy memory response. At least that's a theory. I don't know that for sure, but that might explain why we don't see uniform responses in every individual.
Okay.
And how important, when we talk about antibody response, is it, especially in relation to talking about lasting immunity?
Antibodies are the part of the immune response that can protect you from getting reinfected. There are other types of immune responses, particularly T cell responses, that would not protect you from getting infected, but would protect you from getting disease. It would limit the infection very rapidly, but it's not sterilizing immunity. That's actually one of the forms of immunity that my lab studies very deeply, is what we call tissue-resident memory, the T cells that are left behind after an infection in the lung and airways. Those persist for some time, and they can be extremely effective at providing protection, particularly from very virulent viruses.
And have you guys been able to look at the memory, especially the resident memory population for COVID yet, or is that kind of not happened yet? I know that that's a long-term goal.
Well, you got to think about it. It's not happened yet because in order to look at it, we have to access the lungs.
Right. Mm-hmm. Yeah.
And that you can't do that on a living, healthy person.
Right.
At least not easily.
Yeah.
It's not impossible, but we haven't looked at that yet.
Yeah. Okay. And there aren't any mouse models just yet. Is that correct?
There are not. This virus doesn't replicate well in mice. Okay. There are genetically engineered mice that express the receptor for this virus. Mm-hmm. But it's unclear whether the pathology is exactly the same as in people, because they don't express the receptor in all the same places that a person does.
Got it. So all the research that you guys are doing right now is all based in humans?
That's correct.
Okay, great.
I mean, I'm aware of the animal models because we're on literally multiple calls a week with global experts who are doing experiments in different systems. Yeah. And so that information is really useful to us because it's revealing basic characteristics of the virus.
Right. Mm-hmm. And I'm sure I know right now, is it the SARS model that they're using in mice?
Yeah, it's the same model. They still have to use a transgenic mouse to do those studies. So they're looking at other models like ferrets, guinea pigs, hamsters. I just saw a study, they tried it in pigs and it didn't work at all. So things are moving very rapidly, but it's still early in the response to have all these systems up and running and know which one is best and so forth.
Mm-hmm. Gotcha.
So switching gears a little bit, how does all the research that we've just talked about, how is that going to help inform, politicians, governments, leaders about the public health response and also about reopening the economy and, allowing people to go to restaurants and go to stores and all of that?
Well, I think, and you've heard this is in the news all over the place. We need to do seroprevalence studies. So we need to test people to find out if they have antibodies, if they've been infected, because there are a large number of asymptomatic or low symptomatic infections. And so people may not have realized that they're actually now immune to the virus. Once we know that number gets to a high enough range and we're getting close to herd immunity, that would, again, help us open up different segments of the economy, of our businesses, and so forth, schools.
So can we talk about that for a second? I know herd immunity is in the papers a lot, but I want to talk really quickly about what that actually looks like. So to build herd immunity, how many of us actually need to have been infected?
So we don't know the exact number, but it's probably going to be somewhere around 75%. So I don't want to see us achieve that by infection. Right. I would like to see us achieve that number by vaccination.
If 75% of us need to, get infected, there would be a significant fatality percentage. Is that correct?
Absolutely. Yeah. Which is why we want to achieve that immunity through vaccination and not infection. I think that you don't want that many people to be infected and get sick, even though the percentage of people that develop severe disease or die is not a very high percentage. It's higher than it is for influenza, as an example. But most cases are mild to asymptomatic.
Mm-hmm. Okay.
The problem is we can't predict who is going to develop severe disease, and so you don't want to take the chance.
Exactly. Yeah. Right. Mm-hmm.
Mm-hmm. Exactly. So you do a lot of research on influenza, especially through the National Center of Excellence at the university. Do you think that prior research has helped, the research that we're doing on COVID-19 right now, and has that helped speed up the answers that we're getting to a lot of the questions with COVID-19?
Absolutely. So we learned a lot from the 2009 influenza pandemic. We learned that we were not prepared, either from a research point of view or a public health point of view. We didn't have the infrastructure in place to more rapidly develop and produce vaccines. So in the meantime, and with SARS and MERS coming out, we got prepared. 2 years ago, we went through an exercise with the national network, and we staged a mock pandemic, and we had all the centers respond as if it was a real pandemic, in terms of the research that each center would do and the information they would gather. And we kept track of cost, and how long that took and what things came first. And we came up with a priority list of which research needs to be done first because it's most informative and will change policy. And that whole infrastructure, that whole system was in place when this virus hit. And so we used that experience, that infrastructure, to move the research enterprise forward. So I've been very pleased with how rapidly the research response has been. I'm not so happy with how the public health response has been. And I think that's partly because we're getting mixed messages from some of our leaders.
Mm-hmm.
Yeah.
So how do you think the research that we're doing now, and also kind of the public health response that we're having right now, will inform the way that we respond to future, crises and pandemics?
I hope we don't have another one of these things for 100 years. But if we do, we all now know how to social distance. We know how effective that can be. We know what the downsides are. And so, with all those things in mind, and I think we are testing how they do stress tests of banks, right? We're stress testing our public health and research infrastructure right now to see how quickly it can respond, in what magnitude. And if we have a vaccine by the end of the year or even early next spring, that's still record setting. It usually takes many years to get a vaccine. So, if people shouldn't take that for granted. That's a remarkable achievement.
Yeah.
Yeah.
So we're going to wrap up here, but is there anything else that you would like to say to any of our listeners who, are dealing with COVID right
now? I would say to be vigilant, follow the guidelines on social distancing and hygiene. They are effective. You're not only protecting yourself, you're protecting the others that are around you, and even others around you that you don't know. And I think it's key to maintain that. And even people that have been infected and recovered and may be immune and protected, they still need to observe the guidelines of good hygiene and social distancing. As I mentioned, it's possible to get reinfected and not know it, and then spread the virus further. So, all these things it will help limit the amount of disease. What I would say is what the social distancing has really done for us is it's bought us time, right? We have time to develop antivirals and test them, to develop vaccines and test them. If we had not done any social distancing, we would have overwhelmed the system. There wouldn't be anybody to make the vaccines, nobody to do the research on the vaccines or the infection, and it would have been a mess. So, I got asked several times why we needed to do this and was it really necessary? And the answer is yes, because we need that time to respond. We bought ourselves several months of, we can still function.
Mm-hmm.
Maybe not 100%, but.
Yeah, I think that's a really good point, because I think people sometimes think we're social distancing so that we can completely, just get rid of, it's just going to magically go away if we social distance. But I think we sometimes forget that we're doing it so that we can limit how much cases we see.
Correct.
And so we can up our capacity and we can get these vaccines out. So I think that's a really good point.
I will add one more thing, and I like this quote. It came originally from Michael Osterholm, and he said that we have to learn to live with this virus. It's going to be around. It's not going to go away, and we have to figure out how to live with it. And I think living with it includes having countermeasures at our disposal to control the infection, to limit the severity of disease. And once we have those, we can do a much better job of living with this pathogen.
There is no magic anything. This isn't just going to disappear one day. I think that's totally right. It is going to be, I think, kind of like influenza, where we're going to just have to live with it and it's going to be part of our lives. So we really want to thank you for all that you're doing and for helping, further the research for COVID, because this is going to be seriously, groundbreaking and super helpful for necessary vaccines and all of that. So thank you very much, David. And for all of our listeners, if you guys like the information that we're bringing to you, please feel free to visit our website at humansforeducation.org/COVID-19, where you can learn more about all of our efforts that we are doing out in Kenya to help families in their efforts against COVID and to help feed them during this extremely difficult time. So please feel free to work with us in doing that. And we will be back next week with more information. So thank you guys.